Hi everyone, and welcome to this tutorial about how to create an inventory system in Godot. Let's start. I have a scene ready, I call it main, and I have modified some project settings like the window stretch modes to 2D and keep, and the size of the windows. So let's start. I'm going to create a folder called items. I'm going to create a script called item, and it's going to extend resource because I'm going to use resource to save our items. A resource is a data container, as you can see in the description of the documentation. Resources are used in Godot extensively, like for example for saving animation, textures, audio streams. So let's start. Our item will have a name, a description, and a texture. I'm just going to save these three properties, but you can save whatever you want. As long as the property is unexport, it will going to be saved into a file. Let's not forget to give it a class name as item. Now we can create it from the new resource window, as you can see. I forgot to make the description a multi-line string. This way we're able to write multiple lines in the inspector. Time to create some items. Time to create our inventory. Let's create a folder called inventory, and inside that folder let's create a script. Let's give it a class name. The inventory will contain an array of slots and will also contain the max slot. Let's now create our item stack, which will contain an item and the quantity. Let's give it a class name. I'm going to overwrite the init function and pass the item and quantity as arguments. I'm using self.property because I gave the parameter of the function the same name as the property name. I'm going to override the init of the inventory class to prototype some functionality. I'm preloading the items we made before into an array. In a real project, I will be using a database, be it a JSON file, a CSV file, or a SQLite database. Let's fill the slot array with item stack. For I in max slots is the same as for I in range 0, max slots. If we don't use range, it's going to be implicit from 0 to the number. We create each item stack with a null because there is no item and 0 as a quantity. Now let's fill it with random items to test it. Because I'm using range and it returns a float, I need to convert it as an integer. Let's not forget to shuffle the items. I don't like how I did it, so let's make two functions. One to set an item stack and one to get the item stack. The set item stack function will have an index, item, and quantity arguments. And the get item stack function will only have an index argument. It will return an item stack. Now we can emit a signal every time we set an item stack, so we can update our UI with it. Let's call it a slot change with an index, all content, and new content parameters. Let's now modify the function and save our content into a variable so we can emit our signal. Let's now start creating our UI. We are going to use a banner container because it is a really flexible container. It lets us style its banner, and any control inside it will automatically be resized to the size of the container. Let's save it into its own scene. For the banner background, we are going to use a style box empty. For a background, we will use a texture rect. Let's give it a texture. Let's set the stretch mode to cat aspect covered, because tile mode doesn't work for us. Let's not forget to enable the expand property. With these settings, the size of the banner container won't matter. We add a VBox container with a label center aligned and change the font with the one we did create before. We will add another banner container that will contain the inventory slots. Set the size flag of that node to vertical expand, so it will fill the rest of the vertical space. We will then save it as an scene. We will change the layout of both scenes to full rect because it doesn't matter. We can change the size of the inventory container in the main scene. Let's also center it in the middle of the screen, setting its layout to center and changing its grow direction to both in horizontal and vertical. Doing this, the banner container will grow from the center of its anchors. The items container will have a grid container called item grid. I don't like it too close to the border, so I'm going to use a margin container to add some margins. Don't forget to change the size flag of the margin container to vertical expand. The item grid will have multiple item slots, which we are going to create now. We will use another banner container and we will add a texture rect for the icon. Let's enable the expand property and set the stretch mode to keep aspect centered. The item slot will have a main size of 64 by 64. Let's add a label for the quantity. I want it to be in the top right corner. To do this, I'm going to check the right center of the vertical size flag and set the align to right. We are going to change the font too. We are going to change the item slot background using a styleboard texture. Let's see how it looks. It doesn't look too bad, but I want to make the icon smaller. For that, I'm going to use a margin container. I changed my mind. I'm going to put the label in the bottom right corner. To do this, I'm going to check the shrine end in the vertical size flag and change the margins of the margin container. Time to write some scripts. The inventory will have an inventory and a function called setInventory. It needs to send the inventory to the item container. I like to prefix these variables with an N. I don't like to use getNode or $notepad because they are prone to errors. For this case, I like to use findNode. That's why I give unique names to the nodes I will use in my script. As the documentation states, findNode will find a descendant node that matches the mask. It also says that it is the slowest way to get a node, but for our use case is good enough. Now we will add a script to the items container, and we will get a reference to the item grid node using findNode. The item slot will have another script, and this time we will give it a class name, get the reference of the icon texture and the quantity label. It will also have an item and quantity properties. These properties will have setters. The item slot will also track the inventory index. Time to write the setters we specified before. We are using setters because we want to update the nodes every time the property changes. But there is a problem. If we do this, the game will crash, because when the node is created, the setter will be called, and at that point the icon texture and quantity label node aren't going to be ready. So we will yield until the node is ready. Let's do the same to the setQuantity setter. If you don't know what this is, check the Godot documentation about formatting strings. Let's also guard against null items. For the quantity setter, quantity can't be a null because we set the type to int, but we are going to hide the label if the quantity is less than 1. Let's write a function to set the item and the quantity. Don't forget to use self.item and self.quantity to call the setter. If we don't do this, the setter won't be called. We are also passing the inventory index. And if we don't have an item, set the quantity to 0. In the item container, we are going to add to the item grid all the item slots from the inventory. Let's create a const with the item slot seen. And now, in the for loop, we can instance that scene and add it to the item grid. To test it, let's add an inventory to the inventory container. Time to test it. Let's run the game and we have an inventory, but we can't do anything with it yet. Now that we have an inventory, we can start writing our drag and drop functionality. But before that, we are going to connect the custom signal we created in the inventory to a function in this class. This function will be called every time a slot in the inventory changes, letting us update the corresponding item slot. To do this, we look for the item slot node with the same inventory index and update it. Let me show you what happens when we change the inventory now. Using a timer, we remove the first item of our inventory, and after 3 seconds, the first item disappears. Okay, back to implementing the drag and drop functionality. I don't want to implement it in the item slot scene because it doesn't know anything about the inventory. I will then forward the item slot drag and drop to the item container. While we are adding the item slot to the item grid, we are going to forward the drag and drop using the function setDragForwarding. The documentation explains how to use this function. If the other control isn't an item slot, we return null. We also return null if the other control is an item slot but doesn't have an item. We will add drag preview later. The data the function will return is a dictionary with the item slot node. CanDrop data will return false if the other control is in an item slot. It will return false too if the data dictionary doesn't have the key slot, or if the slot's inventory index is the same as the inventory index of the slot we are trying to drop the data to. The drop data function will swap the items in the inventory using the inventory index of the data slot and the drop slot. We are going to create that function. We get the content of the from and to indices and swap them. I forgot to remove the last test, so I'm going to do it now. And nothing happens. Why? Because something is eating our click event. We can check which control is receiving the click event using the debugger. Under the MISC tab, we can see that the icon texture is the one receiving the event, but we want to capture the event in the item slot node, because it is the node in charge of the drag and drop. We will set the mouse filter property of every child to ignore. Let's see, and oh, I misspelled it. Let's try again, and now it works. Time to create the preview. I'm creating a function where I will instance the item slot scene, set its item and quantity, and make it semi-transparent. I will also create a control pivot to position the preview in the same place the user grabs the item, because by default the preview will be created in the middle of the mouse, and I don't like that. Inside the getDragData function, we call checkDragPreview with the function we just created. Let's see how it looks. Oh, I made a mistake, it's negative position. Let's hide the content of the slot we are dragging. We don't want to modify the inventory directly because it will break everything. So we will just call setItem with a null item. But if the drop fails, the content will still be hidden, and we need to fix that. Godot will notify every node every time a drag and drop operation happens using the notification function. We will listen for the drag end notification and reload the item slot. And that's all for today. See you in the next episode. Bye bye.